Good morning, students. In last Zoom class, we discussed a very important 5-mark question in this lesson, the addition of vectors and then subtraction of vector. Many of you students not attending the Zoom class. So try to attend the Zoom class regularly. We are taking the attendance. Then only your attendance percentage will be increased. Now coming to today's session. Today we are going to discuss another important 5-mark question, that is the scalar product of two vectors. Also we are going to discuss the vector product of two vectors. So listen very carefully. The both product of vectors having 10 points. Listen very carefully. If you are having any doubt, you just call your teacher. Okay, now we move to the topic and discuss elaborately. Now we are going to discuss the first concept, scalar product of two vectors. What is the meaning? If we dot any two vector products, we are getting the product as a scalar. See the definition. The scalar product of two vectors is defined as the product of the magnitude of both the vectors and the cosines of the angle between them. That means if we dot any two vector, we get the third one as a scalar and the form of angle. Okay, angle between the two values. Therefore, if we the two vectors consider a vector and b vector having the angle between this, therefore the product which we get from that is a scalar quantity. Therefore the a vector dot b vector equal to ab cos theta. Here the ab represents, that is the magnitude. Magnitude means only the scalar quantity represents the magnitude. Okay, the magnitude of the a vector and b vector. That means the both a vector and b vector dot we get ab value. This ab represents only the magnitude. Now we are going to discuss some properties of the scalar product of two vectors. Property number 1, the product quantity, which means the a vector dot b vector is always we get scalar quantity. So in left side we are having the vector quantity, in right side we are getting only the scalar quantity, which having a positive value. Suppose the product we getting is in positive value, means the theta will be less than 90 degree. Suppose the value get in negative, means the angle is greater than 90 degree and less than 180 degree. Second property, the scalar product is a commutative. That is, if a vector dot b vector, we get the reverse of the left side, that is b vector dot a vector. That is, the scalar product is a commutative value, commutative property. Third one, the vector obeys the distributive law. What is distributive law? The arrangement of the formula, that is in left side the a vector dot b vector plus c vector is rearranged. By the a is multiple inside, we get a vector dot b vector plus a vector dot c vector. This is called distributive law. That means the distribution of the vector quantity for both b vector and c vector. Property 4, the angle between the vectors. We get theta equal to cos inverse of a vector dot b vector divided by ab. Student, we know if we dot any two vector quantity, we get a scalar product and the angle. Now coming to the formula, we know the a vector dot b vector equal to ab cos theta. Then if we have to find what is the angle between the a vector and the b vector in the magnitude, so we can calculate the theta equal to cos inverse of a vector dot b vector divided by ab. Fifth property, the scalar product of two vectors will be maximum when cos theta equal to 1. That is, when theta equal to 0 degree, the cos value becomes 1. Then therefore the vectors are parallel to each other. That is, the a vector and the b vector are in a same direction, therefore the theta will be 0 degree. Therefore we get, student, see the example. If the A vector and B vector are travel in a same side, we know the formula, that is A vector dot B vector equal to AB cos theta. When the vector is maximum, that is the theta equal to 1, therefore cos 0 equal to 1. Substitute in the formula, we get A vector dot B vector equal to AB 1. Therefore finally we get A vector dot B vector equal to AB, that is in the maximum. Property number 6. The scalar product of two vector will be minimum when theta equal to -1, that is the angle is 180 degree. Therefore A vector dot B vector is minimum equal to minus of AB when the vectors are in anti-parallel. Now we see the explanation. Student, see the A vector and B vector are anti-parallel and joining the angle is 180 degree. Now we know the general formula, that is A vector dot B vector equal to AB cos theta. Now substitute the angle theta equal to 180 degree. Therefore cos 180 value is -1 and substitute in the formula, we get A vector dot B vector equal to AB -1, or otherwise we can say A vector dot B vector equal to minus of AB. Student, next 7th property. If the two vectors A vector and B vector are perpendicular to each other, then the scalar product will be the A vector dot B vector equal to 0, because cos 90 value is 0. Then the A vector and B vector are said to be mutually orthogonal. Now we see the example. So the mutual orthogonal means the A vector and B vector forms the angle is 90 degree. See the diagram. Now we are going to substitute this angle value in the general formula, that is A vector dot B vector equal to AB cos theta. Since we know theta equal to 90 degree, therefore cos 90 equal to 0. And substitute the value in the general equation, we get A vector dot B vector equal to AB into 0, or otherwise we can say A vector dot B vector equal to 0. Next, property number 8. The scalar product of a vector with itself is termed as a self dot product, and it is given by A vector square. So the A vector square is considered as A vector dot A vector equal to AA cos theta. Therefore here that angle is 0 degree, therefore we get A square. So now the square will move in the opposite side, we get A equal to square root of A vector dot A vector. So this is considered as the magnitude of the vector. Now see the explanation. The self dot product, which means the same vector going to multiple. Here the A vector square is multiple with that, we get A dot A cos theta. So A vector square is written as A vector dot A vector. Now substitute the value there, we get A vector dot A vector equal to A dot A cos theta. Since the angle will be 0 degree, therefore cos theta equal to 1. And we get A vector dot A vector equal to A dot A. Since A dot A equal to A square, therefore we can move the square in the opposite side, we get A equal to square root of A vector dot A vector. So this is represented as the norm of the vector. Next, 9th property. In a case of unit vector, that is n cap, we are product the two unit vector, we get the value of 1. Which means if we dot any two unit vector, for example I cap dot I cap, or even j cap dot j cap, or k cap dot k cap, we get the value is 1. The same unit vector is dot product, we get the value is 1. Then 10th property, in the case of orthogonal unit vector. So orthogonal means the value, the angle should be lies at 90 degree. The unit vector of the any two vector, that is it may be I cap or j cap or k cap, the value should be equal to 90 degree. Therefore the cos 90 value will be 0. So therefore we get 0. And last property, in the terms of component, the scalar product of A vector and B vector can be written as, students, Now the A vector and the B vector are written in the Cartesian coordinate system x, y, z axis. The A vector is represented as ax I cap plus ay j cap plus az k cap. Likewise, the B vector also represented as bx I cap plus by j cap plus bz k cap. Now we are going to dot A vector dot B vector and substitute the values, and also in the ninth property we discuss the same unit vector is going to be dot, we get the value is 1. Therefore here the x value ax dot bx plus ay dot by plus az bz, with the other all the terms will become 0. Now to find the modulus of the A vector, we can written as the modulus of A vector is equal to the A equal to square root of ax square plus ay square plus az square. So in the property of 8 we can discuss this value. Students, next we are going to discuss that another topic, vector addition using the component. In the Zoom class, we discuss about the addition and subtraction, how to add our two vectors. Here we are going to use the addition by using the Cartesian coordinate system of the two component vectors. Okay, now we discuss both addition and subtraction using coordination system method. First we are going to discuss about addition. Consider two vectors, A vector and B vector, which is represented in Cartesian coordinate system. That is, A vector is represented as ax I cap plus ay j cap plus az k cap. Similarly, the B vector also represented as bx I cap by j cap plus bz k cap. Now I am going to add the A vector plus B vector, and I get A plus B vector equal to ax plus bx into I cap plus ay plus by into j cap plus az plus bz into k cap. So the same axis should be added and the unit vector will be taken common outside. Okay, likewise for the subtraction also we having used the same method. The xy component only you have to consider. Therefore the A vector minus B vector equal to ax minus bx into I cap plus ay minus by into j cap plus az minus bz into k cap. Students, only we have to consider the same axis in either side of the vector. Students, we having the example 2.4 related to the addition and subtraction. We will discuss in second video.